right, my friends, it didn't say I had to solve it by graphing, which I'm grateful for. So I'm just going to go ahead and get started on solving this one by substitution. So taking that expression that's equivalent to y in row 2 and replacing y in row 1 with it would yield the opposite of x squared plus 3x plus 1 would equal x cubed minus 2x squared plus x plus 3. And boy, oh boy, do we have more than one x term. So let's get 0 on one side. So hopefully we can factor the non-zero side and use the zero product property. I personally prefer for my highest powered term to have a positive leading coefficient. And for that reason, I'm going to move the equation that's on the left side here over to the right side. So okay, so now I have 0 on one side, and then on the other side, I'd have x cubed minus x squared minus x, it looks like, and then plus 2. Did I do that right? Oh no, minus 2x. There we go. Maybe that looked a little funny. There we go. Okay, and then at this point, I do hope before you reach for rational zeros theorem, which is the P over Q thing, that you do consider factoring by grouping. And so if you look at this polynomial as in terms of two groups of equal size, then you'll notice that there's a GCF for the first group of x squared, and then there's a GCF for the second group of, I think I would factor the -2 out. And then let's see what happens when we do that. So we'd have x squared times x minus 1, and we'd have -2 times x minus 1. And what about this says that we're getting away with factoring by grouping? It's that we have this common factor here. And so I'm just going to go ahead and factor that out front. So we'd have x minus 1 times the quantity x squared minus 2. Okay, and then up to you what you want to do with this quadratic factor here. I personally think of it as a difference of two squares. And so a note 2 is equal to the square root of 2 squared. And so that's why I think of that as a difference of two squares. Factors would be x minus 1 times x plus square root 2 times x minus square root 2. Then setting each factor equal to 0 and solving for x separately would lead to three solutions: x equals positive 1, x equaling negative square root 2, and x equaling positive square root 2. Now let's find the y values that correspond to each x value. You could use either equation. I really like equation 2 for its simplicity, so I'm going to use that one. So the y value when x is equal to positive 1 would simply be whatever I get when I plug 1 in. And you could have plugged it in, of course, to row 1 as well. So let's see, what do I get here? -1. Okay, so I think I just get 3 for that one. Let's see, let's get y when x is equal to negative square root 2. That would be the opposite of square root 2 squared plus 3 times the opposite of square root 2 plus 1. And then simplifying that, what do we get? -2 minus 3 root 2 plus 1. And then combining like terms, I get -3 root 2 minus 1. Okay, now let's plug in positive square root 2. All right, order of operations, square, reverse. There we go. Okay, so now let's write our final solutions as ordered pairs. So basically, we're looking at where these two graphs would intersect. And we found out that the two graphs would intersect in 3 places. One is at the point, put 1 in, get 3 out. Another point would be putting negative root 2 in for x and getting -3 root 2 minus 1 out. And then the third point of intersection would be putting square root 2 in and getting 3 root 2 minus 1 out. There we go. And how is it we could get 3 intersection points? Well, If you kind of remember, we've graphed, cubic functions before. So maybe that one, looks something like that. And then you have a downward facing parabola. So I don't know, maybe it looks something like that. There you go. That's how you could possibly get 3 points of intersection. Anyway, the graphs probably do not look a lot like that, but it's just a concept picture. There you go. All right, my friends, this is the last example for this lesson. I hope things are making sense, and I hope you'll ask me questions for the parts that don't. Take care, everybody.